When using MIPS to teach computer architecture, I frequently hear students express concerns about why aren't we learning more popular architectures like x86 or ARM. So let's quickly talk about the similarities and differences between MIPS and these other architectures, specifically x86. One thing I want to emphasize, though, is that MIPS, x86, ARM, all these different processors share a lot more in common than they do in differences in terms of how they approach the design of the architecture. So I'm going to start each slide by highlighting the high-level similarities between the architectures and then talk about the variations in how these different architectures implement these high-level ideas. So for example, both MIPS and x86 are register-based architectures. This means that most of the operations in the architecture will go through the register file, that we use registers, for example, to index locations in memory, that we use it to hold the outcomes of arithmetic operations, and so on. However, the two architectures differ in the number of registers that they use. MIPS, for example, is very straightforward, has a 32-bit register file with 32 registers in it. On the other hand, x86 has a wide variety of registers that serve different purposes, registers of different lengths, and to fully go into the types and number of registers would take more space than we have on this slide. Similarly, in response, the registers in the two architectures have different names. MIPS can just name all of its registers based on numbers, so register 0, register 1, register 2, or it can have specific names for each register, register A0 for arguments, or S for call these save temporaries, whereas x86 has a long range of different register names that do not necessarily follow a clear pattern. You have to know what all the acronyms stand for. Similarly, x86 allows partial reads and writes. So to help explain that first, let's look at MIPS, where basically every time we write to the register file, we're writing to all 32 bits every single time. With x86, you can choose to write an 8-bit or 16-bit or 32 portion of a register. So we don't have to write all the bits every single time. So we can break the registers into smaller registers if we want to at given moments. So these differences allow us to optimize different parts of the architecture. MIPS is generally, I think, easier to understand, is a lot more approachable. It has fewer nuances and details to remember, but it may not be as optimizable for certain operations, such as when we have a load upper immediate instruction that still overwrites all 32 bits. We can't write to portions of registers even if we want to, and that may lead to some inefficiencies in terms of the speed with which we execute commands. As you'll see in every single architecture topic, there are trade-offs based on how we decide to implement our architecture. But in short, both MIPS and x86 use these registers to do the majority of computations. Similarly, both MIPS and x86 use the same basic instruction types and use instructions in the same way, where we have the idea of an instruction memory and a data memory, and we just have a program counter that helps us keep track of which instruction we're executing. So the instruction types that you would see are things like operations, so add or subtract, data movement, loads and stores, and controls, which are branches or jumps. How these instructions differ is in their names, so we don't need to list all the names of the instructions here, and in their instruction lengths. So again, MIPS is simpler here, where all instructions are 32 bits long, which has a nice property that we know that all of our instructions are 32 bits, but can come with some downsides, such as what we have seen with the jump instruction, where we have to fabricate an address from the address field. In contrast, x86 instructions can vary in length from 8 bits up to over 32 bits. This makes instruction decoding a little bit more complicated, but it can make instructions more powerful. For example, a jump instruction in x86 can encode the entire address that we want to jump to, and doesn't have to rely on fabrication like the MIPS instruction does. Similarly, both architectures use ALU flags to signal how to control branches. In MIPS, we use the flags directly as part of our branch instructions, so we send some data to the ALU, and we immediately use that flag to determine where to branch. In contrast, x86 will store the results of previous computations in a condition codes register, and then those codes are used to determine how to branch in future instructions. There's trade-offs, again, with these different designs. They can be faster or slower depending on exactly how you implement each of those instructions. Finally, x86 supports operations that allow us to add registers plus memory addresses and then store that into a register in the same instruction. Whereas MIPS only allows us to do register plus registers into registers. So again, here, MIPS goes for the simpler approach. It's as a RISC architecture, and x86 goes for the more complicated approach, supporting more complicated instructions as a CISC architecture. Finally, both MIPS and x86 support byte-addressable 32-bit address spaces of memory. They're both very similar in this respect. Byte addressability is just very useful when it comes to accessing different types of data, such as characters, or integers, or floats, or doubles. And the 32-bit address space is just directly what we get from having a 32-bit architecture. In contrast, they do have different ways of accessing memory. So MIPS has the pseudo-direct addressing mode, such as what we see with the jump instruction, register addressing modes, like what we see in jump register, register plus offset, which is what we see in our store word and load word instructions, and PC relative, which is what we see in our branch instructions. x86 supports direct addressing, which is something which MIPS cannot support given its fixed instruction lengths, but also supports some of the same things that we see with register addressing mode, register plus offset, has something similar to PC relative called RIP plus offset, as well as other addressing modes such as implicit for instructions like push or pop, and many more addressing modes which we won't discuss at this time. Unlike MIPS, x86 also does not require addresses to be aligned when accessing data, so you don't need to check whether an integer or character is at a specifically divisible address when we're storing them into memory. Finally, x86 supports memory segmentation, but is now being dropped by modern OSs and is even dropped from the x64 standard. So we won't really talk about what that is. If you're curious, you're welcome to go and study about that some more.